Hey there guys, in this video we're going to be taking a look at our Unit 2 post-test. Looking at the first question, they tell us that the table below represents a geometric sequence. They give us the table right there, and then they say determine the recursive function that defines the sequence. So we talked about geometric and recursive functions in lesson 2, so let's take a look back at that table that we were working with. So it says it wants a geometric sequence and it wants it to be recursive. So if I go and I find that form on our table, it's going to be right here. So I'm going to take that and transfer it over to what we're looking at our Unit 2 post-test. Okay, so if we're looking here, you can see I've got the f of 1 is equal to a. Remember, a represents that first term in your sequence. And then we've got f of n is equal to r times f of n minus 1. So from this and the information that they give you in the table, you're going to need to figure out what that a value is equal to, what that first value in the sequence is equal to, and then what your r value or your common ratio is equal to, and then plug those into the correct places in that form. Looking at number 2. Number 2 says Martha works at a small jewelry store. She designs 2 rings in the first hour. Every additional hour, she designs 3 new rings. Select all the functions that can be used to find the number of rings, R of n, she designs in n hours. So with this one, we need to make a decision. Is what she is doing going to be based on a linear function, or is it going to be exponential? And with this one, you're going to use context clues from what's going on in the problem. And with this one, she says she designs 2 rings the first hour, and that will give us our A value. And then every additional hour, she designs 3 new rings. So no matter what happens, no matter what hour it is, she's got 3 new rings. It doesn't increase or decrease based on how far along she's going. She doesn't get tired and make less. No matter what she's doing, she's always making 3. So that's going to be a linear function. And this goes into where they want us to select all the functions that match up correctly. This goes back into lesson 2 when we're looking at those functions. So if we're looking and we want those linear equations, we're looking at all these different, that's an arithmetic sequence. So we're looking at all of these different options that we could have for what the formula is going to be. So I'm going to take these 3 formulas that we have to work with and then transfer them over and start substituting things into the equations that they give us to work with. Okay, so I've taken our linear or our algebraic equations and I've written them out for us. So all we need to do that we need to fill in is our A value and our D value. And I've already told us that our A value is 2. And then we need our D value. So D value is going to be 3. So all you need to do is to take those values now and substitute them into the equation and then simplify as necessary. So like there's A there, there's D there, and then D would go here, and A and D would go in that one right there. And then looking at this one, A would go here, and then D would go here. And then you pick the ones that match up to where they need to go. There will be 2 right answers out of this one. Looking at question 3. Bacteria begins to grow on the water's surface in a non-operational swimming pool on September 20th. The bacteria grows and covers the water surface in such a way that the area covered with the bacteria doubles every day. If it continues to grow in this way, the water surface will be entirely covered with bacteria on September 28th. So this is one from lesson 2 that we did with our explicit and recursive formulas. Instead of playing with the formulas and spending a lot of time in there and making those work, I just kind of make a list that looks like this. So here's my list. And from there, I'm going to go through, and it says that the bacteria grows. So let's say September 1st, we have one bacteria, and it grows in such a way that it doubles every single day. So if I have 1 the first day, I'm going to have 2 the second day, and I'm going to have 4 the third day or the 22nd, and then 8 the next day. Now, from those, you're going to have to continue that process. And it says, when will the quarter of the water's surface be covered? So after you get this whole list done, you're going to need to take that number and divide it by 4. And that number is going to match up with one of those days right there. And that's going to be your answer for that one. Looking at number 4. Number 4 says, in 2006, 5,200 highway accidents were recorded in the city. The number of highway accidents increases by 5% every year. Let Y represent the number of highway accidents X years since 2006. And it says, what type of situation does this represent? So if I go through and I read this, each of those sentences starts varying in a certain way. So it said the first couple words are the same. So the first decision we have to make is whether we are looking at a geometric or arithmetic sequence. And so this one matches up with lesson 2. So geometric, arithmetic, those words we've used with our lesson 1, except we called those exponential versus, remember, arithmetic is linear. So the very first decision you have to make is this exponential? Is it an exponential function or is it a linear function? So, and the part that you're going to want to focus on for this is the 5%. So when you're looking at 5%, is that an exponential function or is that a linear function? So then looking at that next part, we're looking at having a common ratio of 1.5 or a common difference of 1.5 or a common difference of 1.05 or a common ratio of 1.05. So you've got to take that decimal and you've got to plug it into that 1 plus r and simplify it, and that will give you the number that goes in there. So take the 5%, switch it to a decimal, and then plug it in there and simplify, and that will be the number that goes there. Looking at 5. So 5 says the sales of vinyl records have increased due to revived popularity. In 2012, 50,000 records were sold. Every following year, the number of records sold were 1.1 times greater than the number of records the previous year. So what I did for this one, whenever I do these, very first thing you have to, I like to do is I like to make a list, and I'll make my list and be right back. Okay, so I have my list made. We're looking for what happens between 2012 and 2016, and it tells us that the record sales were 1.1 times greater than the ones sold the previous year. So all I need to do is take the 50,000 and I need to multiply that by 1.1, and that will give me amount that is sold in 2013. And that's going to be 55,000 when you put that in your calculator. So then you need to continue this process, and that will give you the amount that is sold in 2016. And you just pick one of those options, which one of those options it is over there on the left. Looking at number 6. Number 6 says, type the correct answer in each box, use numbers instead of words, and use a slash for fraction bars if you need them. And as a hint for this one, you will not need fraction bars for this one. A professor is examining a new strain of bacteria. The amount of bacteria can be modeled by the function S of n is equal to 20 times b to the n, where n is the number of hours and b is an unknown positive base. Based on the model, there were initially blank bacteria. So there's a couple different places that you could look for this one, but we can go back to our lesson 2 chart that we used. And this is most similar to the formula that we have here, except instead of the n-1, they just give us an n. So we're looking at a times r to the x. Switch back over here. I've got a times r to the x is how things are going to match up for our function here. So based on the model, there were initially blank bacteria. And remember, a represents the initial value that you had for that bacteria. So you need to match that into this function that they give us here. And then it says if b were 1.85, if b was equal to 1.85, the hourly percent growth rate of the bacteria would be blank percent. And so from there, you can take the 1 plus r, like we were using in the first lesson, and set that equal to your 1.85. Drop your parentheses because you don't need to distribute anything for this one. And then you can just solve for your rate that way. This formula that we're using right here, it will give you a decimal. So make sure you take your decimal answer and switch it to a whole percent number before you plug that in for your answer. Looking at 7. 7, the table shows the function r, which represents the total cost of a field trip to a science museum in dollars if n students return permission slips to attend. Which function represents this situation? So looking at the 4 answers that you give you don't need to make the decision between does this table represent a linear function or an exponential because they show you. And if you look, they give you that equation in r of n is equal to mn plus b, where b is your y-intercept and m is your slope. And you could use either of those numbers to find you the answer. So remember, if you want to use slope, you're doing y2 minus y1 over x2 minus x1, and that will give you slope. And if you look, I believe all the slopes are different. So whatever slope you find, as long as you did your math right, that'll be answer. And you could also just use the y-intercept. Because if you notice in the problem, all of the y-intercepts are going to be different as well. So you could use the y-intercept from the table to find the answer as well. So just whichever way works for you is fine with me. Looking at 8, Jason purchased a machine for his factory. The value of the machine was $21,500 in 2010. In 2011, the value of the machine was $18,920. In 2012, the value of the machine was $16,649.60. And in 2013, the value of the machine was $14,651.65. Which statement best describes the situation? So if I look, there is the very first option that it gives us is we're looking at increasing versus decreasing. So if you can read increasing versus decreasing out of that paragraph that they give us here, that's great. If not, take a second and make yourself a table and then come back and see if your table matches mine. Okay, so I'm back and my table is over here. And I'm looking at, this is my years, and then this is my amount of money made or lost. So looking at what the table starts, it starts at 21,000, and then as time goes on, the values go down. So this is going to be a decreasing. So this will let us be able to eliminate half of those answers that we're looking at. So then the next thing you have to make the decision, and I won't spoil the surprise for you on this one, but you need to make the decision between, are you looking at an exponential function or are you looking at a linear function? Remember, when you're looking at a linear function, you're looking for that common difference to be the same, meaning the second number minus the first number has to be the same as the third number minus the second number, and so on. Or if that does not end up being the same, for the exponential function, you need to check that common ratio, meaning you need to do that second number divided by the first and make sure that that number that you get is the same thing as the third divided by the second. So try those out, see what you get, and match those up to whether it's an exponential or a linear function. Looking at 9, select the situation in which one quantity is changing at a constant rate in relation to another quantity. So for this one, we're looking at a constant rate, meaning no matter what happens, what year it is, it's always going to be increasing or decreasing by the same exact value. So you'll be able to put your finger on it and say, this year was 5, and this year was 5, and this year was 5, whatever's going on. And it's not going to be like, well, because of last year was this, it's going to be this. So we're looking for a constant rate. If you're looking for more information on this, this is a lesson 1 question. The words that you're going to want to be focusing on out of each of those options: doubles every year, earns 2% interest, 8 times the value, 15 pages each hour. So those are the big phrases you're going to focus on in each of those answers to help you pick what is going to be a constant rate. Looking at 10, this type of question ends up taking things just a step or two farther than I want us to be worrying about for this class. So if we're looking at this one, the answer is going to be A. Looking at the next one, again, this is one that takes things just a step or two farther than we want to work things out for this class. So for your drop-down boxes, that is what you're going to want to make sure your answers match up to for that one. And then looking at 12. With this one, 12 gets into our lesson 4 stuff that we were doing when we were looking at our domain values of things, of our composite functions. So they say let f of x is equal to 5 divided by x and g of x be equal to 2x squared plus 5x. So this is one where they don't tell us what x is, but they want us to tell them what 2 numbers are not in the domain of f of g. So this is one where we take g, since we don't have x, and just substitute it into f. So we're looking at 5 divided by 2x squared plus 5x. So at this point, you need to make a decision about what type of a function do you have. And just in case you forget, let's go take a look at the different tabs that we have. So looking there, you've got to decide which one of those functions do we have. Do we have a linear function, a quadratic function, a rational function, or a radical function? And so then from there, you're going to need to pick what the restrictions are on your domain. Is your domain going to be all real numbers, if you've got linear quadratic? Or if you've got a rational, is x going to be not equal to, I should say, not equal to 0, or is x going to be greater than or equal to 0? So if you decide it's rational, you've got to take whatever that denominator is, set it equal to 0 and solve. Or if you decide it's a radical, you got to take that, set it greater than or equal to 0 and solve from that way. And pick the answer that matches up there. Looking at 13. 13 says the area of a circle is a function of its radius and is given by the function a is equal to f of r is equal to pi r squared. What is the domain of the function? So for this one, you're looking for the domain. Remember that the domain is the x, and they've switched the x in this one to be r. So we were looking for what type of r values can we have. And just a friendly reminder, when we're looking at the equation that they have us working with here, r stands for the radius. So if we're looking at a circle, the radius is going to be there. So they want you to think about what kind of radius values can you have and have that problem make sense. Can you have all positive real numbers for your radius? Can you have all real numbers? So that means positive, negatives, decimals, fractions. Can we have all positive real numbers, including 0 for a radius? And can we have all real numbers, both positive and negative, but not the fractions? So make the decision based on that information and pick the one that matches the best. Looking at 14, this one wants to know which function's domain consists of all real numbers except for -2. So we'll go back and look at the chart. So we're looking for all real numbers except -2. So that means if we wrote it in the same form that we have in our chart, x cannot be equal to -2. So taking a look at our chart, match up to what you need from your table, and solve from there. All right, looking at 15, drag the tiles to match the correct boxes to complete the pairs. Match each function to its domain. So with this one was lesson 5. It's a mixture of lesson 4 and a lesson 5. Most of it is going to be in lesson 5. So with these, you've got to kind of solve them out, see what their domain's going to be, and then match them up based on those. So what I would do is I would solve this guy, figure out what its domain is going to be, and then match it up to one of those answers that they give us here on the left. And if you need the table for that one, there's the table for that one. Looking at the last one, 16. This one is a lesson 5 questions. They want us to arrange the function in ascending order, starting with the function that eventually has the least value and ending with the function that has the greatest value. So this is a smallest. So you want your smallest function there to your eventually the largest function all the way at the bottom. So if we take a look back at the chart that we used to help us set up those things, looking here, we've got a linear function, we've got exponential, quadratic, linear, exponential, quadratic. So this is the chart that we use to help us make those decisions. So remember, we're focusing on these 3 functions right here. And a linear function is going to be smaller than the quadratic. Quadratic is going to be smaller than exponential. And just as a friendly reminder, if we take a look at the graph that we have right here, the green that they have going on right here, that's our linear function. So our green is our linear function, and you can see that it has a smaller value than our quadratic. It doesn't increase quite as fast as the one that has the largest value, which is our exponential function. It goes like this. So that's the thought process behind that. So with that in mind, go ahead and match up those values. And they try and be a little sneaky on you, like with the x squared and the x squared plus 6. Which one would be smaller between those two, an x squared or an x squared plus 6? Likewise, keeping an eye on those. Make sure you pick the one that's the smallest. And then the same thing here. Make sure you pick the smallest between those two first. All right. Well, I hope this helps you out. If you need some help or you have any extra questions, feel free to email Ms. Schaefer or I, or pop in during our live office hours. Link are available on the spreadsheet from 1:30 to 2:30. Look forward to seeing you guys there. Bye.